All right, so this problem, the key here when you're doing a problem like this is determining where am I going to start the motion, where am I going to end. So it says a gymnast is bouncing on a trampoline. On the upward part of the motion, the mat of the trampoline pushes on the gymnast over a distance of 0.300 meters. So because they're giving me that number, I probably want to begin it before that happened so that it will be part of my equation. So I don't want to do it, I don't want to do the problem where the trampoline has already come back to its neutral position and the person on the trampoline is leaving. Okay, I don't want to do that. I want to have the problem where the person is like that, where they've already stretched the trampoline down, so that what's going to happen next is for the first 0.300 meters, so until we get back to the neutral position, for the first 0.300 meters, work's being done. So I could do it from here. Like once I know this information, I could then solve the problem knowing that what's happening. Like you could actually start the problem here. Like I've seen some people who actually solve it from here to there. And they'll figure out, okay, they're at the low point. There's no kinetic energy. When they get to there, they're going to have, it's all going to be kinetic energy. So whatever the work is done over that 0.300 meters, that's going to all be converted into kinetic energy when the person is right there. Well, I don't need to do that and then break, because then from that point, then I could say, okay, it's all kinetic energy here. The person's going to go up into the air, and at some point, it's all going to be potential energy. So rather than having this in-between step, I'm just going to have my starting position right here. So this is my original position, and then I'm going to have the person when they're up here. So that's going to be their final position. Right, so it says, after leaving the mat, the 55-kilogram gymnast rises into the air for an additional 2.0 meters. So that means that from there to there is 2.00 meters. What average force does the mat exert on the gymnast? So we know that when the person is at this location, all of that energy will be potential energy when they're here. And that energy was generated during the first 0.300 meters. So if I write my equation, I'm going to have KO plus UO plus W equals KF plus UF. Now, whatever the low point is, we always make that 0. That way, everything is taken from the low point. And if this is my if my low point is right here, then I'm not going to have any original potential energy. So that's going to be 0. Well, also, when the person is right here, that's when the trampoline is fully stretched. So they were moving down prior to it being fully stretched, and then they're going to start coming up. Well, in between going down and coming up, they have to temporarily stop. So at this point, we know that the original kinetic energy is going to be 0. Now, when the person goes up into the air, when they reach 2 meters above the trampoline, they have to, again, they were moving up, they come to a stop, and then they start coming down. So when they reach the maximum height, the final kinetic energy is going to be 0. So the whole equation simplifies to work equals UF. So I'm going to replace work with force times distance, and I'm going to replace U with mg times the final height. So there's my equation. And the question is asking, what average force does the mat exert on the gymnast? So I'm looking for that, so I just need to move the D to the other side. So we'll get F equals mg HF divided by D. And at this point, the only way you're going to get wrong is if you put the wrong values in for H or D. So if I'm solving this, actually, let me just do it. I guess I have room. So I'm going to have M. No, I'm going to do it down below. So I'm going to have mg, final height, divided by d. So they gave us the mass of the gymnast as 55 kilograms. G is 9.8 meters per second squared. Okay, now the height, the final height. What should I put for the final height in this problem? 2.3. Because if that's my starting point, then I'm going to be 2.3 higher than where I started. Now you might say, well, is there really, should I really just start here because that's when they leave the mat? But think about it. If I have my pen on the table and I lift it up, okay, I did work. It has more potential energy here than it had when it was down there. So I don't have to throw it and have it leave my hand. Whatever its starting point is, and its starting point was right there. So it's going to be 2.3 meters higher than my starting point. So I have to put 2.3 meters as the height. And what's the distance? 0.3. And so the meters cancel out, and I get kilogram meters per second squared, which is a Newton. And so the answer came out to be what? Force equaled what? What is it? (4,132), or if I write it in scientific notation of 3 significant digits, it would be 4.13 times 10 to the third newtons.